Guys, we're going to get on to the lesson. Okay. So this week, Tuesday, we looked at conversions within the metric system. Okay. And we're looking at 3 basic units of measurements. So we looked at distance, mass, and capacity, which is pretty much the same as volume. All right. And what we did was we tried to work out how we can change within the metric system. All right. So what I did last week, Tuesday, was, for example, I did distance. I said to go from kilometers to meters, you need to times by 1,000. To go from meters to centimeters, you need to times by 100. And from centimeters to millimeters, you need to times by 10. All right. And if you want to go from millimeters back to kilometers, you need to divide, right? Divide by 10, divide by 100, and divide by 1,000. Okay, so we worked out how to go from a bigger unit down to a smaller unit, and then from a smaller unit back to a bigger unit. Okay, so we're going to use this diagram. I'm going to keep referring to it. I'm going to leave the measurement one there, the distance one there. We also did the mass one. We had 4 units. We spoke about the standard one, which is grams, and everyone knows kilograms. But there's also a smaller one called milligrams and a much bigger one called tons. Okay, so milligrams, grams, kilograms, then tons, going from smallest to biggest. And we learned how to change between these two. There are no small jumps here. They're all big jumps. We multiply or divide by 1,000, depending on which way we want to go. And I will refer back to this when we do these questions. We had a very brief look at capacity. Okay, now capacity is if you have a container like an ice cream container, if you fill it with liquid, how much liquid is in there? So the standard unit is liters. Okay, so capacity is fluid liquid. Okay, so there are only 3 units in capacity that we talk about. There are liters, milliliters, and kiloliters. All right, so those 3 units are the ones we're going to work with in capacity. And I will refer to these diagrams. So you're going to see me using them. It's not going to disappear. I will come back to these diagrams as we do these questions. Okay, so now we're going to get you some questions. I'm going to do 5. And then you are going to do 5. All right, so you must have your pen and paper and calculators ready because you're going to work. All right, I'm just going to quickly change my share screen so it looks like this. Okay, and Kia, you should be able to see my calculator now. All right, so guys, you should be able to see my calculator on the screen now. The calculator is your friend. Oh, it's disappeared. There it is. The calculator is your friend. This is what's going to do most of the work for you. Have your calculators ready when you are going to start doing your calculations. All right, so in the first example, question number 1, it says convert 5 meters. All right, and I've always written the word here and then the symbol for the word. All right, so 5 meters, which is M, and I want to convert 5 meters into centimeters. All right, so there's centimeters there, and there's cm for centimeters there. Okay, all right, so let's use our diagram for this. So I need to go from meters to centimeters. Okay, so let's go up to our diagram. All right, so if we look at our diagram, I need to go from meters, and I need to use this arrow and go down to centimeters. Okay, and to do this, I need to times by 100. All right, so let's go down to our question now. I need to times by 100. So the answer for question 1, I take 5 meters and I times it by 100. And I will get 500 centimeters. And it's as easy as that. Okay, so we were going from meters to centimeters. Okay, from the bigger unit down to a smaller unit. And like the diagram said, when we do that, we have to times by 100. So all I did was say times by 100, and that gives us 500 centimeters. And it needs to sound right as well. So if you know how many centimeters are in a meter, there's 100 centimeters in every meter. And if I've got 5 meters, there should be a lot of centimeters there. So 500 sounds right. If you're getting 0.5 centimeters, then something's wrong. Okay. So you should look at your answer, and it should look right. So 500 centimeters in 5 meters, that looks good. Okay. So our method is working. All right. We don't really need to do it on a calculator for those of you that want to check. Sorry, my apologies. Let's do 100 instead. There we go. So 5 times 100 is 500 centimeters. Okay, so that was the first question. Let's have a look at the second question over here. So we need to convert 2 tons into kilograms. Now, a ton is heavy. All right, we're talking about the weight of a car now, an elephant. It's a very heavy thing, okay? So we need to work from tons down to kilograms. Okay, so let's go to our diagram. All right, let's remove this highlighting here. I'll put all these pieces back again. Let's just remove the yellow bits and some of the letters. All right, so let's go here. So centimeters, 100. I need meters, and put that back. And then I'm going to go down to the mass one. And this is where we're working today. So we're going to go from tons to kilograms. Okay, tons to kilograms. We're going from a big one down to a small one. So we need to multiply by 1,000. Okay. All right, so let's go to the question. We need to multiply by 1,000. Okay, so answer for the second question. I've got 2 tons, and I need to multiply by 1,000 to get to kilograms, because there's 1,000 kilograms in every ton, and this is obviously going to be 2,000 kilograms. Okay, I'm not going to use the calculator for this. You don't need to check it. All right, 2,000 kilometers, close to that. I mean, the kilo is there, but we're working with weight, so it's going to be kilograms. Very good, Lindsay. Well done. Very good, guys. You're ahead of me. You guys are way ahead of me. All right, let's move on. Looks like you're getting the hang of this. Okay, let's go to question 3. So question 3 says, convert. Now look at this one. This is 0.3 liters into milliliters. All right, from liters into milliliters. So we need the capacity diagram. Here's my capacity diagram. So we need to go from liters to milliliters, and we're going down to milliliters. So we need to times by 1,000. Okay, so I take my 0.3 liters. All right, now I write the liter symbol like this. Okay, it does look a bit funny. It's a cursive L. The reason why I do that is if I write an L like that, some people think it's a 1. Okay, so it's a bit easier to do liters like that. So 0.3 liters, I'm going to milliliters. So I need to times by 1,000. All right, so this gives us, and I'm sure chat's already got the answer there. Exactly. Well done, guys. 300 milliliters. Okay. All right, now, I don't know if you've noticed in all of these examples, we're going from a bigger unit down to a smaller unit, and we had to times every single time. We multiply. Okay, now let's look at the next question. All right, I want to go from 25 centimeters back to meters. Okay, from centimeters to meters. All right, let's go up to our diagram here. I want to go from centimeters to meters, and I'm going to go up to meters. So that's this arrow, which means I need to divide by 100 this time. Going from a smaller unit to a bigger unit, I need to divide by 100. Okay. So let's insert some space here. Need some more paper. All right. So how many do I have? I've got 25 centimeters and I need meters. Okay, so answer for question 4, 25 centimeters, and I need to divide by 100. Okay, let's even use a calculator for this. All right, so 25 divided by 100, and I get a fraction. Let's change it. Use the SD button to change it to a decimal. And if you got decimals, you should always round off to how many decimal places. Can you put in chat? Where are you going to get the answer there? How many decimals should I show? Well done, guys. Well done, Buso. Well done. Yes, everyone's getting it. Very good. Sure, people are on fire today. I think it's because it's good weather. All right, so how many decimal places should I show, everyone? How many decimal places should you always show? There we go. Well done, Ave. In the matric paper, in the front cover, it will always say, well done, everyone, 2. It'll say round off to 2 decimal places unless otherwise stated. So the question doesn't want anything specific like 1 decimal or a whole number or 3 decimal places. You always, always, always do 2. Okay, so 2 is the default. You always do 2 unless they tell you to do something else. Well done, guys. Well done, Itabile. All right, so 2 decimal places. I've got my 2 decimal places there. So the answer is 0.25, and I need meters. Hey, what the question wants? Yes, the question wants meters. All right, so in this case, we went from a smaller unit to a bigger unit. So we had to divide by 100. All right, I'm doing one more, and you guys are doing the next 5. Okay, this question, let's see what it says. It says convert 0.04, that's very small, kiloliters, and I want that in millimeters. Oh, all right. Now, I don't know if you guys can see it, but from kiloliters, let me remove some of the stuff. From kiloliters to milliliters, that's a double jump, okay? We need to go from kiloliters to milliliters. Now, be careful, all right? There's 2 ways you can do this. And I'm going to say this once, and hopefully you guys get your questions right when you try. There's 2 ways you can do this. Number 1, you can try and go from kiloliters to liters first. How? By timesing by 1,000. That'll get you to liters. And then you take that answer, which is in liters, and then do another calculation to go down to milliliters. And you have to times by 1,000 again. Okay. So that's one way to do it. All right. You do 2 steps. You times by 1,000 to get to liters, and then you times by 1,000 to get to milliliters. All right. Or there's another way you can do it. Okay. If you know that it's a double step, then what you have to focus on is these 2 numbers. You have to times by 1,000 once, and then times that answer by 1,000 again. And 1,000 times 1,000, I don't know if anyone can tell me in chat, what's 1,000 times 1,000? Ah, people have got answers already. Oh my gosh.
All they want to do is just provide you with answers. I love how they are 1 step ahead.
Yeah, they are. They just want to go like, Mr. Dale, please just shush. Let's just get on to this now. All right, but let me just explain to you. To get from kiloliters to milliliters in one massive jump, one big jump all the way there, straight there, without going through liters at all, no stopping through liters. You say 1,000 times 1,000, which is 1 million. All right. So if you know 1,000 times 1,000 is 1 million, you can do it in one jump. I'll show you it works. But let's do the 2-step process because I'm sure you're all doing that. All right. So the answer for question 5, I need more paper. All right. Using lots of paper tonight. All right, answer for number 5. I've got 0.04, if I'm not mistaken, kiloliters. Yeah, and I need to times this by 1,000 to get to liters. We're doing 2 steps here first. Okay, so let's use my calculator. It must do all the work for me. Times 1,000, I get 40. 40 what? 40 liters. You must write the unit there. 40 liters. Now I need to take my 40 liters and times that by 1,000 again to get my milliliters. All right, so 40, my answer's there. I'm just going to say times my answer by 1,000. Okay, and hey, you guys are too good. Too good. All right. All right, everyone's getting well done, everyone. Well done, Sam. Good job. All right, well done to everyone. Now, let's test if my other theory works. All right, let's test if this other theory works. So 0.04, 1,000 times 1,000 is 1,000,000. So I'm going to times this by 1, 1, 2, 3, 4, 5, 6. 6 zeros in a million. Hit enter. Yes, it does work. All right, so if you want to do one step, if you know 1,000 times 1,000 is 1,000,000, you can. All right. Okay, guys, that's me done. I'm going to talk no more. You guys are going to do the next ones. All right. Now, at the rate you guys work, I reckon this could be done in about 6 minutes. Not even. So there are your questions. You're going to do them, and we're going to check them. Off you go.
Now this is your time to shine, guys. You've been providing us with such nice answers. I can't wait to see what you're going to show us now.
All right, I'm sure we're not going to do it, but I'm sure if we unmuted all their microphones here, we just hear a lot of tapping noises. Those calculators must be working overtime.
Yeah, and those pages flipping because they are definitely showing calculations, which is taking up all their space.
Very good. You must show always show calculations.
Oh, and I love how people are not forgetting their units.
Yeah. All right, Kia will always remind you to always show your units. All right, answers coming in for A1.
Kamkhelo is already on the go. They're busy with A2.
That's good. Good time. I hope it's good quality. The speed is incredible. I hope the quality is good. Well done, guys. All right, looks like most of them are on question 2 now.
Yeah.
Don't worry if you're not on question 2. Everyone goes at their own pace. As long as you work carefully, that's the most important thing. All right, looks like some people are on question 3. All right, we've got a couple of minutes to go, but don't rush. You keep doing your thing. You guys are doing incredibly well. All right, Tapela looks like he's finished. Yeah, it's incredible watching everyone work. Everyone's concentrating.
Yeah, no, hey. Like you said, if we could hear the sound, I think we'd just hear calculators, papers flipping.
Yep.
It would be amazing to witness.
All right. We'll give 1 more minute and then we'll start going over these. But everyone seems to be doing exceptionally well.
Guys, please remember to stay muted at all times.
All right, a few more minutes. Just going to turn this off quickly and then on again. All right. All right. Everyone should be done, or at least nearly done. We'll wait a little bit more.
Sakile is done.
Well done, Sakile.
They're ready for the corrections now. Like
Okay.
they can't wait.
Now I can feel it. All right, 17,400. Just writing the last one down here. Those are milligrams. All right. Okay. Here we go. From the top, A1. Answer for question 1. Convert 2 liters to milliliters. To go from liters to milliliters, we'll have a quick glance at the diagram. We need to times by 1,000. Okay. So 2 times 1,000. That should give you 2,000. And like here always says, show your units. All right, 13 grams. That needs to go into milligrams. And if you go up to the mass grams to kilograms is over here. Okay, we need to times by 1,000. All right, so again, times by 1,000 here. And that should give us 13,000 milligrams, show your units. All right, 1,500 milliliters to centimeters. We're going from smaller to bigger here. So we're going to need to divide. And from milliliters to centimeters, we just have to divide by, sorry, not milliliters. Wait, it's millimeters. Millimeters to centimeters, we have to divide by 10. So that should give us 150 centimeters. All right, 0.04 meters to centimeters. We're going from big to small. We're timesing now, and we're going to times by 100. So that should give us 1, 2. So that should give us 4 centimeters, if I'm not mistaken. Let's check it. So 0.04 times 100. Yep, 4 centimeters. Okay, last one. 17,400 milligrams to kilograms. That's a double jump. Okay, so let's do 2 steps here. Let me create more space. It's 2 steps. So from milligrams to grams, we're going to divide by 1,000 to get to grams first. This is going to give us 17,40 grams. And then 17,40 grams. Divide that by 1,000. Because I need my answer in kilograms. So that's going to be 0.123. So 0.017 kilograms. Let's check that quickly. So 17.4 divided by 1,000. That should give us 0.0174. Now, this answer here at the end, 0.0174. Most of you showed me the whole number, which is fine because we actually want to see how it looks at the end. But if they ask you to round off, then this should really change to 0.02 kilograms. Okay, so be careful with that one. So if they're saying round off to 2 decimal places, round your answer to 2 decimal places, the 0.0174, we have to look at the second decimal there, which is the 1. Will that 1 change? Yes, the 7 is bigger than 5, so the 1 becomes a 2. So that leaves us with 0.02 kilograms. And this funny symbol here, you don't have to draw the symbol like that, okay? This means equal to, exactly equal to, and this means almost equal to, approximation, okay? So it's not exactly equal, but it's an approximation, which is close to equal, rounded off. Okay, so I use that symbol. Don't have to. I'm just showing you that this is the rounded off number over here. Okay. All right. Very good. Very, very good. It's just not that difficult. Okay. As long as you remember the diagrams, it's not that difficult at all. Are there any questions so far before we move on? Does anyone have a question? If you do, raise your hand before we move on. If there are no hands in the sky, then I'm going to move on to the next section. It looks like everyone's keen to move. All right. Here we go. Now we're going to get to something really interesting. What about area and volume conversions? Okay, for example, here's a question. And look at this face. It says, if, all right, yeah, this is a bit nerve-wracking. What about area and volume? Look at this question. Convert 7 square meters into square millimeters. Oy, oy, oy. All right, what's going to happen now? All right, square centimeters into millimeters. Okay, now this is not the normal one where we go from meters to centimeters. Now everyone knows to go from meters down to centimeters, we have to times by 100. Okay, this is a little bit different, but it's easy to understand because if you know the old diagram from meters to centimeters, this one here, we just have to change this a little bit. Okay, so watch this. I'm going to use red pen this time. So meters squared to centimeters. Oh, we're not doing centimeters, we're doing millimeters. My bad. We're doing millimeters squared. Let's add an M there and add another 0. From meters squared to millimeters squared, okay, look at the 2's. Those are the squares. You don't just times by 1,000. You have to times by 1,000 squared. Okay, that's the only difference. All right. So if you have meters squared and you want to go to millimeters squared, you have to times by 1,000 squared. All right. The same is true if this question wasn't talking about area, but it was talking about volume. Okay. So what if we had cubic meters, meters cubed, and we wanted to go to millimeters cubed, cubic millimeters? What do we do then? That's easy. Meters cubed to millimeters cubed, you times by 1,000 cubed. Okay, so let's see how that works in this question. I'm going to go back to the squares, put my squares back, and I'm going to just keep this diagram over here on the side. I'm going to make it small. I can sit there on the side. So let's see how the calculation works. I need to go from 7 meters squared to millimeters squared. And my diagram says I can't just times by 1,000 like the old one was. I've got to times by 1,000 squared. All right. How does it look on the calculator? All right. So it's 7 times 1,000. And then here, there's a button. I don't know if you can see it. Let me try and make this bigger. I've got a little tool here. Oh, that's not it. This is it. Yeah. All right. There we go. Okay. So look at the screen there. You'll see this is the big version of the screen. And right here, there's a button called X squared. All right. That's the square button. You press that and it puts a square on any number you want. All right. And you press equals. Oh my gosh, it's huge. Yes, it is huge. We're timesing by 1,000 squared, which is massive. All right. So yes, it is supposed to be big. Okay. Don't be surprised when you see a very big number there. When you start squaring numbers, they get very, very, very big. Okay. So the answer is 7 million square millimeters. Okay. So how do we go from meters squared to millimeters squared? We have to times by 1,000 squared. Okay. Yes.
Ompila says that they are lost, and then Ornama is asking, can they ask a question?
Sure, guys. Raise your hand. There's a button on the Zoom function. Raise your hand. Raise your hand and we can answer any question. Why don't we use squared at the 7th? Ah, okay. Yes. Good question. All right. Aka, I'm going to answer your question next. Let me just deal with this one and then we're going to go to Aka after this. Okay. So a square centimeter is a block. It's a unit of area. All right. And we have 7 of these. All right. Dot, dot, dot. And there's a whole lot there. I'm not going to draw all 7, but there are 7 of these square meter blocks. All right. So the square is not on the number, it's on the units. All right. So this here, meters squared, is a type of unit of measurement. So if I remember correctly, right at the beginning of Tuesday's lesson, or this could have been last week's lesson, I dealt with volume. Let's have a look. There was a diagram that I used here. All right, here we go. All right, this will explain to you. Okay, so if you look over here, this is going to come up next week. We've been talking about length, which is one-dimensional. Length is just one dimension of measurement. So if someone says you measure this length, you get an answer, let's say 7 meters. All right. But if you have a rectangle which has 7 meters, a length of 7 meters and a width of 3 meters, all right, you have to times those numbers together using the area formula. All right, so you're going to say 7m, 7 meters times 3 meters. Okay, this gives you 21 square meters. Okay, now square meters is a unit of area. All right, m without the square is a unit of length, but meters squared is a unit of area. That's how we know it's area. Okay, so when we go down to our question here, when they talk about square meters in the question, they're talking about area, not length. All right, so meters squared is area. All right, so this 2 that you see here doesn't belong to the 7, it belongs to the m. It's square meters. All right, so I wrote the word there, square meters, and then the way to show it in symbol form is m to the power of 2, m squared, square meters. Okay, right, Aka, please turn your microphone on. You had a question? Please turn your mic on, Aka.
Sir,
Yes.
I just wanted to ask, how did we get to the 7 million? Because I got 49 million, something like that.
All right. Now, what you guys are doing, those people who are getting 49 million, is what you're doing is you are taking this 2 and you are putting it on the 7. Okay. The 2 doesn't belong to the 7. The 2 belongs to the m. So if I have to write 7 square meters in words, it's 7 square meters. All right, if I write it in words, it's 7 square meters. So these 2 words here, square meters, that's what gives me m squared. That is m squared. All right, n to the power of 2 square meters. The 7 is just a value on its own. So the 2 in my statement here, when I say 7m squared, the square doesn't belong to the 7. It goes with the m. Okay, and we don't use it in the calculation. It's on the letter m. We don't use it in the calculation. But the 2 on the 1,000 belongs to the 1,000, and that must be used in our calculation. So look at my calculator. All right.
Dale, please hold on.
Sure.
Charles Juma, can you please stay muted? I think you can continue now.
All right, thanks, Charles. Okay, so look at my calculator. I don't type in 7 squared because that square, that little 2 doesn't belong to the 7, it belongs to the m. It's just a way to say square meters. So you mustn't put that 2 there. All right, you just say 7 times 1,000 squared. All right, and you get 7 million. Okay. Okay, I think someone else also raised their hand.
I think it was Yamkelani.
Yes,
Yamkelani.
Tapelo, that's Yamkelani. Do you want to ask a question, Tapelo? That's exactly what they did, to put the 2 on the 7. All right. Anyone else have a question? Otherwise, I'm going to move on and give you one to try. All right, we've got 9 minutes left, so I want to give you this one to try before we go. I can give a yes. You put the square on the 7. All right, you mustn't put a square on the 7. The square belongs to the letter M, not the 7. All right, here's an example for you. Oh, yeah. All right, hold on a second. The gremlins are back. Okay, here's an example for you. I want to work out. I have 0,00034 square meters. Okay, the square is not on the number, the square is on the meters. And I want this to change to kilometers squared. Ah, there's a challenge. I want you to convert 0.00034 square meters to kilometers, square kilometers. I want to see if you can do that. All right, there's the question. I want 0.0034 square meters in kilometers squared, please. Kilometers squared. Onam, the letter doesn't represent one. That letter is just a way to name the type of units of measurement we are using. So M for meters, K for kiloliters. So this is not like core maths when the letters are variables and they represent numbers. It's just a name. It's a name we give to the type of units that we're measuring in. Okay, so the 2 is not going to be multiplied, or the 2 is not going to belong to a 1. You don't have to change the M to a 1. It's just a name. All right, I could have written the word square meters, but instead of writing the word square meters, I just wrote M to the power of 2. Okay. So we don't have to do any math with that power of 2 and the M. It's just a name. Hey, these guys are fast.
No, definitely. Hey.
Alrighty, that's what we're looking for. Kilometers squared. Oh, Charles, you got KM4. I think that 4 is supposed to be a 2. Right, we got
But their fast
squared.
fingers mean that they were very attentive. So that is good.
All right, let me quickly do the sum. Okay, I'm going to draw the diagram. Okay, let me draw the diagram quick, show you how I work it out. All right, I've got meters here and I need to get to kilometers. I know from meters to kilometers, it's this way. All right, and I have to divide by 1,000 normally, but this is meters squared. And I'm going to kilometers squared. So I need to divide by 1,000 squared. All right, so let me do that on the calculator. So 0.00034 divided by 1,000 squared. All right, don't worry about that. That's my calculator saying I want to be fancy. I'm telling my calculator we're not supposed to be fancy. We want simple things. All right, we don't want fancy things. All right. Let's try again. So 0.00034 divided by 1,000 squared. Okay. All right. 3.4 times 10 to the minus 10, which is very, 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 very small. That's why my calculator is doing this. It's super tiny. It's super, super tiny. Now, you guys who've got getting 340, you multiply it instead of dividing. All right. These guys who are doing 340, you multiply it. Okay. So look here at the diagram. If you want to go from meters to kilometers, you have to divide by 1,000. But if you want to go from meter squared to kilometer squared, you have to divide by 1,000 squared. So this answer here has got 10 zeros. So it's 0.2, 3, 4, 5, 6, 7, 8, 9, 10. And here comes the 3, 4. So that's exactly what it is. All right. It's a tiny, tiny, tiny portion of a square meter. How much is that if it's in a big kilometer squared? All right. Manjabulo, just quickly answer your question, and then I need to show the quiz results from week 1. Manjabulo?
Sir, I don't understand how do they get the 3.4.
3.4. Who's getting 3.4? Oh, on the calculator. Okay, so on the calculator, because this number is so small, if you look at the answer on the screen there, because this number is so small, it can't actually fit on the calculator. So what the calculator is saying is we don't have enough zeros, so they're showing it in scientific notation. All right, it's just a fancy way for the calculator to show too many zeros that fit the screen. So it's what it's saying is it's 3,4 with 10 zeros behind the 0. All right. So I know how to convert scientific notation into normal notation. So it's just that there's not enough zeros on not enough spaces on my calculator screen. Okay. That's the only reason why I've got 3,4 times 10 to the minus 10. All right. But it's a very, very, very small number. It's got 10 zeros in it. All right. Now, I want to show you something very exciting. So the first week we did a quiz and we got the results from the quiz. All right. And I'm very happy to report that we have Sonken Toyake, Kamohelesiwe, Lindsay Mati, and Sonaro Soreko are all getting 100% so far. There was another one. Oh yes, all those guys got 100% for their quiz. Okay, some people did their quiz in guest mode and they got 100% as well, but we couldn't name them because they're all guest mode participants. So when you do your quiz, please don't enter in guest mode. Try use your username and then we can call you out. A lot of people got 93%. And what was interesting was the people that got 100% took the longest to do the test. Okay, so there were people that took very long to do the test, and they were the ones who got the highest marks, which shows you that you need to take your time and work very carefully, or you don't have to rush it. It's not a race. All right, so well done. You can see on the screen there. We've got some people, 1, 2, 3, 4, 5 people who have got 100% for their first quiz. Well done. Okay, congratulations. Now, today is also quiz day. So after this, Kia's going to put, yes, it's exciting for us. Yes, good question. Kia's going to put a link to the quiz in the chat. So before you go, you're going to do 2 things. You're going to answer the poll, and then you're going to get the quiz link, and you can do the quiz. You don't have to do it tonight. You can save it for tomorrow. But please go ahead and do the quiz. It's going to be on everything we've covered in this week. Okay.